Yo, guys. Hey. So back to this dang problem, man. It's day 17. Still trying to figure this one out. Yeah, let's go back to this. Make this bigger. It's not really like editing too much on this one. Yeah, maybe the biggest possible, so where the font doesn't get like weirdly bolded. Text size is about as big as this browser here. So don't even need this to be. I'm just kind of like do this sort of thing. So back at this, what kind of layout did I have before? I feel like it was easier to draw stuff. The terminal was kind of overlapping with the. Okay, we had the input. The puzzle input. Yeah, that's pretty good. Yeah, it's pretty good to do that. And then got this here. I don't even think we need this description too much anymore. We kind of have most of it. Kind of like right here. I don't think we really even need the. Yeah, it is kind of comfy to have it up there. Maybe kind of, right behind it. So we made some progress last time. We were basically trying to see like where we left off was we're like, all right, let's get a setting of the input where we could just like at least print out a 2 first and kind of get a handle on that. So we were kind of working backwards. We're like, all right, how do we get a 2? Well, B basically has to be like right before it prints out to the screen. Like B has to be basically 2 followed by whatever bit, because like when we shift it to the right by 3, it's going to be 2. So like that's good. I think it might be kind of helpful just to maybe label these so I don't have to keep rewriting out the equation. So call this like B1, A1. So now B2 is equal to B1. And then this is A1. Yeah, sure. All right. Whatever, C1. It's going to be shifted over by B2. And then B3 becomes this thing. And then A2 becomes A1 shifted over by 3. And then we had a B3, so this is B3, and B4 becomes this. And then we have B5 becomes that. That goes out to the screen. So basically we need it to be so that B5 has this form. So so what is B5? We kind of just going up one line, we have that B5 is equal to B4. Wait, did I screw up on the thing here? B4, why wouldn't this just be 4? Let's just 4, right? Yeah, because like we just set it to 4. So all right, should be B4. So yeah, whatever. You need it to be that B4 is equal to this. And so how do we get that? Like B4 is equal to B3 XORed with 6. So I wonder if we can kind of even like solve this algebraically. Like what if we what if we said that x something like this is equal to like B3 XORed with 6. And if we could somehow do like the inverse XOR of it's almost like the like inverse XOR of B3 on this side, and then like B3 of the inverse of the like inverse XOR over here of on this, then we could kind of like cancel these out and wait, no, we have to solve for B3. So we want to kind of like do the inverse XOR of 6 on this side. And then we would want to do like the inverse XOR of 6 over here. And this would cancel out and we would get B3 is equal to this. It's kind of weird to think about this. Like what is this number here? Like what property does it have? It's basically, this is like 2 to the 0, 1, 2, 3, 4. So this is like 2 to the 4 here, 16. So basically the number has to be, it has to have a 2 to the 4 in it. I'm trying to think like how we would phrase that. Like if you just had like a decimal number and you had like 1, 2, 3, maybe it's like, maybe just like a decimal number like this. So this would be decimal. And so this is the ones place, and this is the tens, and this is the hundreds, and this is the thousands place. And so if you say that there's a 10 here, then what? What can we do with this number if it has like a 10? I guess it is, I guess if we divided it by 10, like let's think of two numbers which have a 10 and which don't. So let's think of like 100 and let's think of like 110. Both of these are divisible by 10. In fact, if you have any number to the like including or like to the left of this spot here, like the tens place, it's going to be divisible by 10 because like 10 divides like 10 divides 100, 10 divides 1,000, whatever. I feel like the thing that, yeah, I guess kind of like really just going back to this, like what this is saying is that if you kind of like shift this thing over, if you kind of shift it over to get to a point where I don't know, like the tens thing is just like all the way to the right. So 110 becomes just like 11. Then like this spot here has to be a one. So I don't know, it just has to be a one. So can't really think to characterize it any better way. Yeah, I kind of want to ask ChatGPT about the inverse Zor thing. So it's like, can you take the inverse Zor? Like if I have the expression x Zor 5, can I do like y is equal to, can I do the inverse Zor to the right side of both equations and solve for x? Let's just say we have like a, I don't know, 4 like that. Yes, you can solve for x. Zor is its own inverse. Oh, dang. Whoa. That's crazy. And Zor is commutative too. Like if you take like x Zor y or y Zor x, it's the same thing. All right, that's cool. Commutative and associative. It's reversible. I don't really know what that means, but that's cool. That Zor is its own inverse. So yeah, basically we would just like take like this thing and Zor it with 6. Yeah, doing out the equation. Okay. So if you kind of fix B4, it's equal to 10. We actually like do this? Like, do we even have to write it like that? Like, what if we just said like, what if we just started with the equation that B4 shifted to the right by 3 is equal to 2, is equal to 2. Like, I guess it's like this. It's like the binary thing. We just started with this equation. And then we're like, okay, like that has to be the case. And we have that B4. It's almost like we have like a system of equations here. B4 is equal to B3 Zor 6. And we have that B3 is equal to B2 Zor C1. Let's just C. Then we have that B2 is equal to B1 XOR 5. Then B1 is equal to A1 shifted over by 3. And it's like, we kind of start with like B4 has to be this. And we want to solve for the value of A. Yeah, this kind of gets into like systems of equations to where it's like, are there multiple solutions for this like system of equations? Probably. Maybe we could simplify this a little bit. Like, what happens if we just had like if we just like considered one step up? So like we're just maybe just looking at these two. So we're like, all right, B4 has to be this. So yeah, kind of like looking at this equation by itself. This equation is under constrained, like underdetermined. It's because so like what values of B4 would satisfy this equation? Yeah, it's basically like these values of B4 where could we say basically that B4 maybe we could bound B4 like B4 it's greater than or equal to 1 like this, and it's less than or equal to 1, 0, 1, 1, 1, like when they're all ones. Yeah, like just by this equation here, I guess. These values of B4 satisfy like this equation. I don't like the B here. We'll just say, yeah, it's like 1, 0. So by adding in another equation, are we kind of further constraining this? Where like B4 also has to be B3 XORed with B6? Or 6? What if we just solve for B3? XORed with nothing. Yeah, this goes to, this is 0. XOR this with 6. So we have that B3 is equal to B4 XORed with 6. So it's almost like, I guess we're kind of like starting in this range here, and we're like, all right, now if you kind of think about, oh, that's interesting. So remember from our last time, we determined like the range that XOR could put you in. So if you kind of like take this equation and you say like B4 XORed with 6, we said that this thing could be -6 or +6. So if it was the smallest possible, it would basically be this thing -6, and like this thing -6. And this is B3, I guess. So so B3 has to be in this range. And if we kind of like go up another thing, what was B3? B2, B3 is equal to B2 XORed with C. And then if we just XOR both sides by C, we get B2 is equal to B3 XORed with C. So Wait, did I mess up here? So we had this, and then if you just take B4, oh, okay, no, we good. So we know that B3 is in this range, but then if you do B3 plus C, just kind of running out of room to write on the over here. I guess I don't know. We could like get rid of this. Basically, have now like B3 XORed with C is greater than or equal to. We have this thing minus 6. Minus C is kind of like the range there. And then this thing 1 minus 6. Wait, this should be a plus 6. I like adding 6. Plus C. And this is equal to B2 now. So now what's B2? How do we do this? We started with B1. I think I'm all messed up with my subscripts. No, I guess we were just working backwards, but this is like in reverse. So we have B4 is equal to this. So now we have B2. So now let's kind of get B1. So B2 is equal to B1 XORed with 5. And so let's XOR both sides with 5. So we get B1 is equal to B2 XORed with 5. So you basically now have like B1 is less than or equal to this minus 5 here and like plus 5 over on that side. And then just B1 is equal to A bit shifted by 3. So I guess, yeah, I mean, this is going to keep its thing. So we would just like shift this whole thing by 3 and shift this whole thing by 3. And we basically say that A is less than or equal to this. A is greater than or equal to this, and it's less than or equal to this. So we're basically saying if A is greater than or equal to this number here, so like A depends on C. It matters what C is. And if it's less than or equal to this, then you will get a 2. That's what we're basically saying. We can test that out to see if we got the math right. Which, by the way, I don't know. For some reason, yeah, I think that's like a good amount to kind of discover. And I think I'm going to take a break, actually. That was cool. It feels like we're really getting somewhere. And this guy in my Advent of Code group, who's also like solved every problem so far, he said he solved it with math, with like a math equation. And so I feel like we're on that path to discover that. So it's pretty cool. Thanks for watching, guys. Thanks for hanging out. I will see you later. Peace.